good morning, all are not present here. Today we are going to see a seminar conducted by our student Ashwin on the topic B+3. And Nandini, I'm working as an assistant professor in National College of Engineering and the Department of Computer Science and Technology. Let us start our class.
First, we are going to see about indexing topic. So, it is a technique for improving database performance by reducing the number of disk access necessary when a query is run. So, the main purpose of indexing topic is to search and retrieve the data, to collect the data from the database. So, when a query is run, it used to reduce the number of time. Okay, so there are two types of indexing. One is single level and another one is multi-level. The B and B+3 comes under the multi-level indexing. Okay, so in a single index there will be two sectors. One is key, another one is the data reference. So this is a single index. It contains the two parts. One is key. The key holds the element which is a reference to get the data. So here the value will be stored, and here the key element will be stored to search and collect the element from the database. So this is the structure of the indexing. Okay. So, and there are two types, one is single level and multi-level. Our topic B+3 and B3 comes under the multi-level indexing. Okay.
What will be the main purpose of this B3 means? Any idea have? First one is efficiency. Second one will be a retrieval for larger amounts of data. These two are the main things we are going for this B3 and B+3 indexing.
So B+3. So B+3 is a data structure concept as we learned already. So it is a self-balancing tree for efficient data storage and retrieval. So here also in DBMS also its purpose means we can efficiently store the data and retrieve. Okay. So by using the key and the data reference value, we can able to retrieve the data easily. So we are considering it as an efficient way. So the here in the B+3, the parent node will appear in the leaf node. It means the parent node is A. The parent node will also be appear in the right side of the leaf node. So this is the main difference between the B3 and B+3. And the third condition is when order is equal to n, the number of keys allowed here is n-1. If our order is 5, only the 4 elements can be fit into. Fit means inserted into the into that storage. Okay. So we are going to we are going to insert these values by following the B+3 concept. So here the order is 3, so we can able to place only 2 elements. So order is 3, so n-1, n is equal to 3. So n-1 means only 2 elements only can be able to place. So keys allowed here is only 2. So while we are inserting F, so 1 is less than or equal to 2, so it follows the order property. And we have an empty space and we can able to place S without any violation. And in step 3, we are inserting Q, where we have only 2 space. While we are inserting the element Q, it violates the order property. So to avoid this violation, we need to take the common element from this 3 element and we want to place it in the root value, and we want to follow the binary search tree. It means the root value will be in the mid, the element which is left side will be in the lesser than will be in the left side, and greater elements will be in the right side. So the common element among this is Q. So F is less than of Q. And S is greater than Q. Here the root node is being reflected in the right pointer. As we see in the B+3, the parent node will be reflected in the leaf node. Okay, so it also follows that condition, and all 3 elements are inserted without violating the order property. Okay, and in step 4, we are inserting the element K. So element K is less than of Q. So we have a placed here. So it can be get placed in the left pointer of the queue. Okay. And in the right pointer, as it is, the Q and S will be placed. Next, we are inserting the element C. So while here when inserting C, again we used to face the violation. Again it violates the order property because F, K, C. C is also less than the element Q, so we can able to place only two elements in the in our space. So and again we are taking the common element from this and we are following the binary search concept. So here the elements will be. So here we have an empty space and among F, K and C, C is the common element and the C element will be in the root node along with the element Q, and in the left side of F, the element C will be placed though it is lesser than F, and in the F's right side the element F and K will be placed. Here F is considered as the root node and it is reflected, and K is inserted because of the right side because F is greater than the K, and it also these two elements are less than of the Q, so they are in the left pointer of Q, and in the right pointer of Q the element Q is placed and S is also placed. Since it is Q will be Q is a parent node, it should be reflected in the right pointer, and S is greater than the element S. So why we are saying this is efficient means the values which we need to retrieve all will be in the leaf node. So here we never consider about the key element, as all elements has been inserted in the leaf node. We can straight away directly go and search the elements in the leaf node and we can retrieve them. So this is why this method is considered efficient of the data storing and retrieving. Okay.
So what you have understand is from the root node which is less than you should place it at the left side, and which is greater than you should place at the right side. So if the property is getting violated, you must follow the steps as said by the student. Thank you.